Good evening, humans. Today I bring you František Apfelbeck, who runs the food hacking base here and does a lot with fermented foods, and Arndt Marijnissen, Justa, who helps him with electronics because they're building an automatic incubator. Enjoy.
Okay, hello, greetings to everyone. My name is František Apfelbeck, and this is Arndt Marijnissen from Technologia Incognita. Sorry. We are today about presenting a proposal or call for participation for the experimental incubator project. This project is basically about building a device which will allow for easy and simple fermentation. And we will go through different stages, what we did already, where are we now, and what are our, let's say, short, medium, and long-term goals. Before we go up, I would like to present a little bit of my history, what I do, and where I'm kind of coming from. I have been traveling around the world for quite some time. My backgrounds are biotechnologies, so I studied on universities, Czech Republic, Holland, Ireland. Later on I decided that applied research, or let's say fundamental research, is not exactly for me. So I moved on and I started to actually do biotech, got in touch with the hackers in Noisebridge. And during the years, I started to really kind of, see myself positioned within the hacker movement, enjoying its qualities, and going over some of the not so good things that happens. At the moment, I personally, as a fermenter or quasser, person who does fermentations, need a device to make my activities more feasible, more easy. That's something what I would like to have, but it's very hard to get it if you don't build it by yourself. So basically, I started to talk and work later on with people around the world on an idea to come together and create something what would suit my and proposals of many other people who have issues with fermentations. And as me, presenting fermentations, promoting them, I would like to help them. So, we created some time ago a group which is called Food Hacking Base. We started to be present on some of the major events like CCC Camp in Finofurt. We have been in Ulm lately. We come to the CCC conferences where we invite people to come and join us in activities about food hacking, brewing, etc., DIY, bio. In our case, I would define maybe our activities around combining the ancient knowledge, which is here for a very, very long time, with modern science and technology. These two groups of slow food people and technological people are kind of, in opposition many times, and we would like to bring them together. We also hope to promote more of the social aspects of the hacker movement and bring in basically people in the hackerspaces, in the events, together through the food, drinks, and really interesting things which I believe should be followed and developed. Now, what is the experimental incubator? For what purpose we would like to do something like that? As I already mentioned, the main idea is to do fermentation easily and reliably. In this case, you would like to grow cultures. Some of them are more difficult, some of them are more easy, complex. There are many variables. And we would like to ferment, meaning that we would like to have products. You can imagine brewing beer. Something what you would like to do, you need to take care about the microbes, but it's not sometimes so easy. So we would like to devise a device which should improve this process, and that's what the experimental incubator should do. Now, there has been too much text on this slide, but I will run through it quite quickly. This is not something what no one tried before or what doesn't exist. There are lots of solutions. I would distinguish them or divide them in several categories. One is commercial solutions. In that category, there are high-end. That means laboratory incubators, industrial kind of style incubators, They are well designed, they are reliable, they are not open sellers, and they are definitely not cheap. Generally, for a home purpose, too expensive, $1,000, $1,500, not a problem. Now, after this, a commercial, let's say, alternatives which are cheap. You know them from the eBay and many other places. Bread making machine. Nice example, you can get it around $58, let's say. Yogurt making machine. In this case, it's the design is kind of modular, so you need each machine generally for each thing. They are not very reliable in the long term because they are devised not to basically be in that way, and definitely there are no open source. So that's something of this pity. Of course, there are DIY buyer options. There are many of them open source, which is great. Unfortunately, many of them are not very well documented, and even if they are well documented, you need most of the time quite pretty good knowledge in making them happen, making them work, keeping them up to date, and doing what you want. So if you are not kind of techie, you will have a problem, and many people in slow food movement, in fermentation, they are exactly the people who are as far from the technology as possible. So these things kind of, they are there, but they are missing something what we need. Now, give me a second. I have just authentication of the virus network. Nice. So, if I summarize it, what is missing, and that's basically what we want, in a way. We want a device which will allow us for a variety of fermentations. So it's not just one ferment, one temperature, whatever. There are many. So you can do many things. We would like to have something that is quite pretty easy to control. So it's, it has some decent interface, which you can go through, and you don't have to tinker with it too much. Low cost is clear, and of course, and that's really kind of at the core, I would say, it should be easy to replicate. You should be able, if you are around different parts of the world, do kind of what we do, follow us, and use it. Of course, at the beginning, there are prototypes, so things are a bit more challenging, but still, this is something where we would like to really keep at really core. Now, of course, we would like to do the upgradability, and open source is clear. Principles and guidelines development. I will go through it quite quickly because I mentioned some of them already before. Open source, that's for sure. Should be versatile. Again, I'm repeating myself in this case because this is very important. We would like to have something what lasts. So many of the devices built today, as you know, they do not last for very long, and definitely it's hard to improve them. They are designed like that. We would like to do something what is the opposite. Environmentally friendly, that's something what we hope, and we would like to work towards. But let's be honest, at the beginning, we will have to definitely make compromises on that because that's, beautiful future, but the road towards that is quite pretty tough with the current, setup. Now, project continuity, this means, as most of the people believe, if they like something and they would like to see it grow, it should have the future. So that's part of that. Now again, I have to confirm the virus network, interestingly. Next slide, I will quickly talk about what I managed to do with others. In this case, mostly in South Korea, where I built basically a first functional prototype under with the funding of the Susubri Academy, which is a brewing facility education center of the Kyonggi University. If I simplify it, I use Arduino. With the help of electronic engineer, we make it nicely work, measuring the temperature, and switch on, off, basically Peltier circulation system, which make our incubator heat up the box to up to 42 degrees. Cooling was unfortunately not a success in this case, so we could go up, we couldn't go down. Concerning this, I like that it worked even for weeks. So it was quite pretty sturdy. It fermented what I needed, so I achieved the things which I like. I really wonder what I do wrong in this case. And What I didn't like was, again, the heating and cooling. I didn't like that the electronic part was not, it was not basically recorded, documented in a way which would be easy to replicate. In this case, I'm really grateful for the help, but it was basically all the wires around, and for me, for example, repeated, not the slightest chance, as a kind of not very advanced. So that was the shortfall. Now, we have moved forward, and many thanks to this movement, to Art Marinsen. We met over years ago, and we talked about this, I would say, endeavor for some time. And in the last year, we started to really progress. So I would like to now ask him about talking the more technical details, which I, as a biotechnologist, I'm quite weak, and he has knowledge which I'm missing, and I think that there's a big chance for the contribution on this side. I'm positive about that.
Thank you. Can everybody hear me? Yeah, works fine. Perfect. So we've been philosophizing a lot about how to build something up that you can replicate easily across the world without too many things that you need to put together as a non-technologist. There's a lot of people spread out that are doing slow cooking, fermentation, etc. And the only thing that they really want to do is get something to brew. They don't want to be stuck trying to solder a 144-pin FPGA type thing on an SMD board. It's very strange how people don't like that type of stuff. So what we did, we devised a way of starting something out that is really easy for people to get into and then move forwards when it's needed. If you could put the video feed of the camera on the screen, please. Yeah, perfect. So this little very non-charming device is currently where we stand. I will show the obligatory Arduino board that everybody has laying in their drawer by now. There's a really, really great little board by the guys from DF Robot, which is upside down. It's a little LCD panel. It has a couple of switches on it, which you can buy for around $9 on eBay or somewhere else. It's well documented. There are libraries available that will allow you to interact with the LCD and the keyboard in such a way that you will have menus that you can go down through, et cetera, et cetera. And then there's a very, very simple board, which is the thing that people will have to put together by themselves. Now, this board will basically connect a temperature probe. Many people might know this. This is an encapsulated version of the Dallas one-wire 18D20S or something like that. I don't know exactly, but you'll find them everywhere. They're around $4 by now. This one is sealed, so you can actually put it into a fluid, which is great for fermentation. We put a jack plug on the back. You can put any kind of plug on there that you want. But it basically allows you to use this little prototype board that you buy for $2 for the PCB, a couple of headers, a couple of jack plugs, a couple of resistors, and then you basically have an infrastructure that will allow you to use an Arduino to drive an LCD that you control via a couple of buttons and that can measure temperature. The next step, of course, is to drive some kind of thing that either heats or cools. That in itself is also a solved solution. This is, some people might know it, it's a solid-state relay. These devices have come down a lot in price recently. This will set you back about $6. It has a connection for 240 volts or 120 volts, depending on where you buy it and what you use it for, on one side, and the other side takes 5 volts inputs that allows you to drive high current, 25 amp current in this case, with a device that's €6. It's optically isolated, so if anything spills on one side and you short circuit your heater or your fridge or whatever, your other side is still safe. So your Arduino connected to your laptop will not fry the rest of your system. You encase this in a little box so that it basically allows you to just plug it in. Oh, sorry, there. And on the side is the connector that leads to the prototype PCB. This is just one way of building it. And the only thing that I haven't shown yet is another component that we deemed important enough, which is going to be a pre-made little board that is fresh in its shrink wrapping. There we go. This is a really nice one, also from the guys from DF Robot. This is a device which has a real-time clock, an RTC on it. You can see the little crystal on there, which will allow the device to know what time of day it is, even when it's being unplugged. There's a battery connector on the back that allows you to be able to unplug the device, put it somewhere else in the room, then replug it in, and it will still know, oh yeah, I was in this fermentation for 3 days. It's now this date, so I don't have to continue from the beginning. I know where I was in my fermentation. It also has an EEPROM on it, so you can store all kinds of programs and other information about the fermentation that you're doing. And the basic idea is to use and leverage an amount of knowledge and libraries that are available for these devices and these boards in the Arduino space currently. It is not maybe the intention to stick with the Arduino if the Arduino is too constricting or too expensive, because there are cheaper devices out there. But as a way of making a prototype that people can replicate easily and order the parts for all across the world, this seems to be the best choice for now. So with that in mind, we've documented a lot of what we've did already on a wiki. It's not on your slides, I think. Did you put it in your slides? No? All right. So I can name the name. It's wiki.techinc.nl. It's related to our hackerspace. I will supply people who are interested with the URL in particular. If you search for fermentation, you will find the project page. And it has all these parts there, where you can buy them, what they will set you back, and the libraries that you can use readily made that allow you to interact with these parts and build an interface. The next step up, we have a little bit of software already that measures temperature, et cetera, et cetera. But the next step up is to make a little interfacing library that will allow you to be able to say, okay, I just want to know the temperature of temperature sensor 1. I don't care on what pin it is connected. I don't care if it's an Arduino or a BeagleBone or a Raspberry Pi in the future. I just want something that, you know, takes the pain of programming out of it. Because the end result of this stage should be that we can have some software, not hardware, but software tech savvy people who are into fermentations or slow cooking or beer brewing, able to program a device which will safely let them switch things like 220 volts or Peltier elements and allow them to create programs for the fermentation itself. So a schedule like you should heat it for 30 minutes or 2 days, and then you should cool it down. It depends on the type of brew that you want to do and how complex you want to make it, what you want to do in those programs. So there might be presets that we allow people to make and ship all across the world for the other devices. But this is basically what this platform is for. The end result, the final product will probably be a completely different form factor. So that's where we are right now. I think that is all I can say on the hardware side, apart from one little bit. Lars has been really helpful in doing pioneering work on Peltier elements. So this is a fermentation box, an incubator box. It's basically a styrofoam box. And this has a little, this has a great Peltier element in the middle. And the Peltier element is cooled on both sides, the heat transfer is done on both sides by cooling elements. These are just CPU coolers. And it allows you to take the heat out of your fermentation and into the outside world or the other way around. The styrofoam case would in this case be here, and then basically a Peltier element allows you to transfer heat from one side to the other in both directions, either direction, by putting the plus or the minus on different poles of the device. Very nice piece of magic technology, and this is a great little object that will allow you to displace about, I think the effectivity is not that much, but probably 30 watts of energy, at least at 60 watts inputs. But that can be used because in some places, keeping something warm is actually not the problem. Keeping something cool when it's getting overheated, like in South Korea, is actually the challenge. Here in Germany, it's probably likely the other way around. So these types of devices solve that. And an abstraction layer in the software will allow you to choose between all kinds of scenarios where you might have active cooling, passive cooling, either solid state relays to drive a fridge or a heater, or you can use a Peltier element where you drive the voltage up or down and then cool or heat. So that's the status right now.
Yep. Thank you very much, Alan. This is exactly where as I said, beaker. Can I have the screen? Go to the screen. I'm not sure if we are on.
Could the presentation come back?
Yes.
Yep.
Yep. Are
And
we there?
again.
Yes, we are there, as usual.
Whoops.
Bit of magic. Okay, sorry, I will have to go back where we have been. Just give me a second.
You're still in slide mode.
Yep. Trying to do my best. Why do we not move?
This is the next slide.
Uh-huh. And somehow I don't move
Oh,
forward.
you cannot select the slides there. You need to go
I
back
see,
forward.
yep. Okay, we are a bit farther. Yep, control it. Here we go. Now, this is going to be, I would say, quite flexible part, but there are some things which we already know and which we are basically doing, and we want to have them done sooner better, but we don't want to go too fast. Short-term goals. We are now promoting food hacking here in the conference. As you can see, we have some parts already done. We'll be progressing on that. After the conference, I am hitting the road for 5 weeks, touring the different parts of the Europe and hackerspaces for a food hacking tour. And the experiment incubator is a big part of that. Importantly, I need to do my ferment, so it's a basic. We would like to build around 3 incubators in different places and have them running as a prototype, finding out what we did well and what we didn't. So this would be actually, let's say, next month and a half, 2 months stage, getting 3 at least machines running. Closer to each other, better constant design. Now, we would like to monitor temperature, so we know the temperature inside, especially hopefully outside. We would like to do the heating, so we can control the temperature. Cooling would be nice, but if things don't go so well, heating, I would be happy for now. It's winter here. Concerning the team, we basically would like to have 3 to 5 people at least to start to kind of move it forward. Thanks to Lars, Arnold, and actually several other people who I could ask during the years and about things, I kind of improve my knowledge and get my ideas clearer. We are already on the way. At the moment, it looks like that, as like Arnold mentioned, the main bottleneck is the software. That's something basically programming code. That's something I think what really will be the challenging part of the next, let's say, step or 2. So definitely, we would like to get someone who is either interested in fermentation as programmer or it's programmer interested in fermentations. Just kind of the combination of someone who would like to join and consume. How much more?
6.
Okay. So we would like to do something as a medium goals as experiment kit, which you can basically get. It kind of functions quite well together. The heating, cooling, that's kind of something what will be later on. How long does it take? It's a question. As you can see that this is, let's say, 2014, so the next year. I would like to suggest some crowdsourcing campaign to basically get us started, to get some funds, so we have actually money which we can spend on another prototypes. And I am always, for getting basically some support wages, for people who are working on the projects. Because if you don't work on what you kind of like or love, you have to work on something else, and working just for the money, it's not, I think, the best option. Now, we need to grow as a group. That's something which is really important, and I would like to really promote and keep the group at least for some time together. Many times things kind of get later on, kind of splits, new things, people would like to do something different, kind of ways, fine with me. But I think for this first year or 2, it would be really nice to keep the team together, kind of working on one kind of thing. Now, software code needed, software code person needed, that's something what you mentioned already. Long-term goals, 2015 and after, this is something kind of a little bit of kind of hope and desire. I would like to keep this as a kind of open source platform, you know, something, some device which can be taken farther, can be improved. Seems to me that really the label of the open source allows a really beautiful growth of many wonderful products. So because I believe in open source and I see the feasibility and kind of, you know, the progress on many projects, I would like to keep it there. So definitely for that. I would like to invite also people, if they have time on this conference, to pop in Hacking Base and see actually Lars' prototype, which is now in this moment cooling. So doing exactly the challenging part, you know, in our place. He had already that on home and worked well. So if you like to see prototype in action, please come. And I already kind of mentioning crowdsourcing campaign in the future. We will be hitting the road, we will be getting resources. So just to make the point clear, short-term goals, next 2 months, 3 experimental incubators, let's say build. After that, we would like to focus definitely, you know, more and more on software and more prototypes. And the crowdsourcing campaign, long-term kind of, you know, project would come together. We will see how it's evolving. I would like to ask before I conclude, Arnd, you know, if you would like to add something?
Well, yeah. So I have the parts for 4 of these devices with me. Minus 1 solid-state relay, which you should be able to pick up anywhere. I believe the cost worked out around 35 euros for the whole thing. If you're interested in dropping into this project and you'd like to have a base a prototype available to work with, please contact us at the Food Hacking Base or at Tech Inc. We are the ones with the LED fireplace on the first floor. Ask for me, and I will help you out. Some of the devices will have to move to other hackerspaces around Europe when you're doing the tour, but 1 or 2 are available for real enthusiasts who want to drop in. We'll kit you up with a development set of libraries and reference material that we have, and you should be able to get going. I think that's it, and thank you for your time.
Thank you, everyone, and thanks to Arnd, Lars.
Maybe any
others.
questions from the audience? Could maybe to the microphones? Yes.
Hello?
Yeah.
Okay. You've been talking about this incubator, and now what I'm interested in is whether you have also thought about supporting the growth of plant in general, so food hacking, because many people I think are interested in trying this out and planting their own food at home, and the ability to control this with microcontrollers is very interesting, I think.
Mm-hmm. So in this project, it's mostly about fermentation. This is also partly my background. I do beer brewing, and he, of course, is very much involved in fermentations as well. I've done a number of things with aquaponics, running a... Sorry? Oh, I can't because it's a clip-on mic. I'm as close as I can be. Can you hear me? So basically, I've done some work on aquaponics control systems. Basically, this could be used greatly for the same purpose, but you would have to do a completely different code base. But the device can do it. It's not much different, the type of requirements that you have. You might want to do some extra sensors, but that's it.
Yeah, I have a question for František.
Yep.
You mentioned a few times that you're a biotechnologist.
Yep.
So, you know, fermenting beer and other things is relatively harmless. But do you see this as a device where I know there's a biotechnology hacking movement, at least in the US, where you would actually ferment genetically modified organisms? And do you think that you should at least put in a word of caution that this is a self-replicating biohazard that you that could do interesting things to the world if you flush them down the toilet. You probably need to refer people to Bill Joy's talk and article in Wired magazine, Why the Future Doesn't Need Us, that was pointing out some of these things. So I would like to know what your position on that is. Thank you.
Thank you for the question. It's kind of an interesting one in this case. I have to say that I'm trying to avoid the GMO kind of discussions, partly because my background is actually genetic engineering of plants. So I had to go through these things in my time quite deeply. Just to answer quickly, this device is one of the parts, or basic part is basically variable. So you can actually use it for nearly whatever you want. If you want to do GMO, you will be able to do GMO. If you would like to do natural occurring microbes, basically growing them, you can do that. From my point of view, just to kind of say my opinion on so you can use it for purposes which you decide. The responsibility is on your side, of course. It's also partly on my side to develop something what you can use for its purposes. I understand that. Just to say simply, GMO, from my point of view, I believe that they are future, but I definitely do not believe they are our future, or at least nice future in the hands of companies like Monsanto and big corporations, which I think are showing clearly their lack of respect of ethics, let's say, and sometimes even a human life. So just, that's my opinion on that, and it's more opinion, so I hope I answered the question. Next one?
One more question after that.
So you've got the sensors and actuation and sort of microprocessor level control figured out. What about the actual incubator itself? Because now you've got a heat source or a heat sink in this box that you haven't described at all. What does the rest of the incubator look like? I see you've got a polystyrene box, but I mean there's a lot missing.
Yeah, to be absolutely honest, I'm sorry, I forgot to add 2 pictures of the prototype in Korea. The basic prototype in Korea was done from MDF boards around, so box, quite sturdy, heavy, screwed together. Insulation material was polystyrene, some pier boards would be better definitely, and inside was a polyethylene boards for easy cleaning. And on top it had basically cut and a circulation system through the ventilators, heat sink, and the fan basically running the air through. Sorry for that, it should be on the slide, but more or less, kind of, if you can imagine big microwave kind of, more or less this style, more robust, more prototype style.
Dark.
Sorry?
Dark inside.
Dark?
Dark.
In this case, yes. No light. No light needed.
Well, thank you for your presentation, and if anyone still has questions, come to the food hacking base and ask the speaker.
Yep. Okay. Thank you for your time.
Thank you.